A linear equation has two variables, x and y, or it can have two variables, x and y, and also has an equation. But a linear inequality has these inequality symbols. So I'm going to read them. This one's less than or equal to, greater than or equal to. So all of these are written in standard form, where you have ax and by and c. A solution of a linear inequality in two variables is an ordered pair that makes an inequality true. So part one, tell whether the ordered pair is a solution of the inequality. So what you want to do is plug in x is -1 and y is 9 and see if it's true. If it's true, then it's a solution. So I'm going to do 2 times -1 plus 9 and see if that's less than -3. So is -2 plus 9 less than -3? Is 7 less than -3? Nope, that's not true. So no, this ordered pair is not a solution. Letter B, I'm going to plug in x is 2, y is -2. So is 2 minus 3 times -2 greater than or equal to 8? So is 2, this will turn into 6, greater than or equal to 8. So is 8 greater than or equal to 8? That's true, because 8 is greater than or equal to 8. So that's true. So it's yes. It's a solution. So just like inequalities, if you remember on a number line, when you graphed like x is greater than 3, there was an infinite number of solutions. The same goes with the linear inequality. There's going to be an infinite number of solutions. So what you're going to do is just graph a line like you always have, but you have to consider whether to make the line solid or dashed. Okay, so a dashed line means that the points on the line are not solutions. So you want to use a dash line if you're using the symbols less than or greater than. You're going to use a dash line. A solid line means that the points on the line are solutions. So you're going to use a less than or equal to or a greater than or equal to. So notice on here, the origin 0, 0 is on the dash line. So 0, 0 is not a solution. Okay, so anything over here that's shaded would be a solution, all of these ordered pairs. But up above the line, they are not solutions. So I'm going to clear this out here. This is graphing the line y is less than 2x. So what you would do is you'd start at 0 because the y-intercept is 0 and go up 2, right 1, up 2, right 1, and connect the dots with a dashed line. Okay, because it's dashed because it's less than. So it's not equal to, so you don't connect the dots. Now, the second thing you have to do is shade and create what we call a half plane. So half of it's shaded, half of it's not. That's why it's called a half plane. So to figure out where to shade, I keep it pretty simple. You can do test points, but what I do is I think about a ladder. So if this is your ladder, the only way that the person would walk up the ladder is in this situation right here. They're on the ladder. If they're on this side of the ladder, they're going to fall off. So you'd walk up the ladder this way. And because it's less than, I shade under their feet. Okay, you shade under if it's less than, under the ladder if it's less than, over the ladder if it's greater than. And I'll do examples on the next part. Okay, down here we're going to graph. So what you have to remember about when you're solving for y with these is if you divide by a negative, you need to change the sense of the inequality. So for example, down here, if you were solving this to graph it, when you divide by -3, you'd get y is greater, and your slope is going to be negative 1/3 x, or negative 1/3, and your y-intercept is going to be negative 2. So you have to change the sense of the inequality when you multiply or divide by a negative. So I'm going to do these two examples up here. I just want to make sure I talked about this because that's a common mistake, is forgetting to divide. When you divide by a negative, you switch the direction of the inequality. So letter A, I'm going to graph the line like I normally would. So in this case, I solve for y. Oops, and I added 2x, and I meant to add x. So I add x to each side. That gets rid of the negative x, and I divide by 2. So I get y is greater than 1/2 x, because over here I have 1/2, plus 1, because 2 divided by 2 is 1. So I didn't have to change the direction of the inequality because I'm not dividing by a negative. So I go ahead and graph the line like normal. So I put a y-intercept at 1, and I go up 1, right 2, up 1, right 2, up 1, right 2. Now, two things I have to consider. One is whether or not this is a dashed line. Okay, and then 2 is where I shade. So this is going to be dashed because it's greater than. It's not equal to. So I make a dashed line. Now then I put my person on a ladder. So this is greater than. So I shade above the line, above the head, above the feet of the ladder. Okay, letter B. I graph the line. This is nicely already in slope-intercept form. Go down 1, right 4, down 1, right 4. It's going to be a solid line. So I connect this. And then if I think about a ladder, person on the ladder, walking up the ladder, I shade underneath the ladder. And if you're not sure about the ladder too, what you can do is pick a test point. So 0, 0 is right here on this side of the half plane. So if I plug in 0, I get negative 1/4 times 0 plus 6. So 0 is less than or equal to 6. That's true, so I shade on the side of that test point. If it's false, you have to shade on the opposite half plane, the opposite side of the test point. Okay, so C and D are special instances because these are horizontal and vertical lines. So if you remember, y equals a number is a horizontal line, and then x equals a number is a vertical line. So if I have y is less than 3, this is going to be a horizontal line at 3. So I make a dashed line. Now the reason I make it dashed is because it's less than. And then I'm going to shade underneath. All of these numbers are less than negative 3 on the y-axis. So here's your y-axis. These are the numbers that are less than 3. Okay, letter D is going to be a vertical line, and it's going to be a solid because it's equal to. So I go over to the x-axis at 4, make a vertical line. Now on the x-axis, these numbers are greater than 4, so I'm shading this way to the right. So those are special cases of vertical and horizontal lines. Okay, another application. You can spend at most $12 on red peppers and tomatoes. Red peppers cost $4 a pound and tomatoes cost $3 a pound. Write and graph an inequality that represents the amount of red peppers and tomatoes that you can buy. So we have red peppers and tomato. Those are my variables. So, and then identify and interpret two solutions of the inequalities. So first I'm going to write an inequality using T and R that relates to you can spend at most $12. So if you have at most $12, you have less than or equal to $12. Red peppers cost $4 a pound and tomatoes cost $3 a pound. So it doesn't matter where you put the peppers or tomatoes. I'm going to put the peppers on this axis and label it peppers. And then over here I'll put tomatoes. So because I put tomatoes on the y-axis, I'm going to graph by solving for y, which will be my t. This is also one that you can graph using R and T intercepts. I'm going to use intercepts. So when I find the R intercept where it crosses the R axis, I'm going to set t equal to 0. So in that case, if I set t equal to 0, I'll get R is 3. So one ordered pair is going to be 3, 0. And then if I set R equal to 0 and solve this, t will be 4. So I'll have the ordered pairs, I'll go up by 2s. 2, 4, 6. Actually, I'll go like this. 1, 2, 3, 4, 5, 6. Just so it's spaced better. And then tomatoes, 1, 2, 3, 4, 5. So I'm going to plot the points 3, 0 and 0, 4 and connect. And it's less than or equal to. So I'm going to shade underneath. So all of these points right here represent the ordered pairs that are solutions. So for example, if you bought 1 pound of red peppers and 1 pound of tomatoes, this is what this ordered pair would be, you would be paying less than $12. And anything on this boundary line is also a solution because it's a solid line. I just also wanted to show you an example where you might have to make your own inequality. Okay, so there's some like that in the assignment. So if this is my linear inequality, what I want to do first is find my slope and my y-intercept. So my slope is going to be up to right 3. So my slope is going to be 2/3. And my y-intercept is going to be -2. So I'm going to write y, and I'm going to leave some space for my inequality symbol, and then 2/3 x minus 2. So because I'm shading under the ladder, it's going to be less than. And because it's solid, I'm going to put less than or equal to. So there's my inequality.